In this video, we're solving problem 4.4.23 from section 4.4, which is all about counting, from Essentials of Statistics, 6th edition by Mario Triola. The question says, a corporation must appoint a president, a chief executive officer, a CEO, a chief operating officer, that's a COO, and a chief financial officer, that's a CFO. It must also appoint a planning committee with 3 different members. There are 16 qualified candidates, and officers can also serve on the committee. Then we're asked to complete parts A through C below. Part A asks, how many different ways can the officers be appointed? Now, I started to make this video, and then I had a problem. I accidentally stopped sharing my screen rather than stopping recording. So the answer is already there. Let me show you how to find that answer. To do that, I'll show you my paper. Okay. So it's asking me how many different ways the officers can be appointed. And you've got a president, you've got a CEO, a COO, and a CFO. Well, if I have 16 qualified candidates and all of them are qualified for all 4 of these roles, I've got 16 options for the president. But assuming that the president does not also serve as the CEO, the COO, or the CFO, after I choose one person for that office of the president, I only have 15 qualified candidates left for CEO. And then after I choose that person, and I've already chosen the president, there are only 14 qualified candidates left, for COO. And then we've got 13 folks left for CFO. So if I multiply all of those together, I get 43,680. So there are 43,680 different ways that the officers can be appointed, provided every officer is only holding one office. And we've got 16 qualified candidates where each of those candidates could play any of those roles or serve in any of those roles. So let's go back to the homework problem. Oops, sorry about that, trying to find it. I don't know why it's not showing the right screen. There we go. Now the homework problem says, how many different ways can the committee be appointed? And then it asks us just to fill in the blank in order to answer that. So I'll stop sharing my screen again and I'll show you my paper. Okay, how many different ways can the committee be appointed? Well, we've got 16 qualified candidates and we are appointing a planning committee that has 3 different members on that planning committee. Well, let's think about it. If there are 16 qualified candidates, I've got 16 options for the first member of the committee. I've got 15 options for the second member of the committee. And I've got 14 options for the third member of the committee. But let's say I chose Sally, Joe, and it's hard to think of a name. I'll use my sister's name, Jade. Okay. Let's say you chose Sally, Joe, and Jade for the committee. So first you chose Sally, then you chose Joe, and then you chose Jade. Well, that's exactly the same thing as if you had chosen Joe first, and then Sally, and then Jade. Because when we're choosing a committee, it really doesn't matter who we choose first. We could choose Joe second, or we could choose Joe last. It doesn't matter. Either way, we still end up with the same committee that includes Sally, Joe, and Jade. So I've got Sally, Joe, and Jade here. I could have chosen Joe, Sally, and Jade. I could have chosen Joe, Jade, and then Sally. That was a possibility as well. So Joe can go first and then I can choose Sally or Jade, or Joe can go first and then I can choose Jade or Sally. Or I could choose Sally first and then choose Joe or Jade, or then I could choose Sally next and then choose Jade or Joe. Or we could have chosen Jade first and then chosen Sally and then Joe. Or we could have chosen Jade first and then chose Joe and then Sally. But all of those are considered exactly the same committee. It doesn't matter which person got chosen first. At the end of the day, when they go to their committee meeting, they're all going to be there together. So all 6 of these are going to be counted as the same, or we want to count them as the same. The problem with this is that it takes order into account. It's saying I had 16 options for that first committee appointment. I had 15 options for the second committee appointment and 14 options for the third committee appointment. But when I multiply all of these together, I'm actually counting these as separate appointments. This is taking order into account. I don't want to take order into account. So I need to divide by the number of ways that we can arrange those 3 people in order. Because I basically have 6 times as many different ways on this list than I actually have in terms of the committees. So we have to divide by the number of ways those 3 people can be arranged, which is dividing by 3 factorial. 3 times 2 times 1. So let's see, what do we get? We got 16 times 15 times 14. And then we're dividing by 6 because we counted all of these guys as separate. So we end up with 560 different ways to appoint the committee. Now this is the intuitive approach. We can also use the formulas. We'll come back to these problems using the formulas in just a moment. If you are a person that prefers not to use that intuitive approach, if you'd rather have a formula, we'll go over that in just a moment. Or rather use a formula. Okay? And then lastly, it says, what's the probability of randomly selecting the committee members and then getting the 3 youngest of the qualified candidates? Okay. So let's write that question down. Okay, I'm going to share my screen with you now, or stop sharing my screen with you now. I mean, share my paper with you now. Okay, so we're asked for a probability this time. And we want the probability that we find when we select that committee, we choose the 3 youngest qualified candidates. And that can be found by finding these 2 numbers. Well, we want the number of ways that we can select that committee in the denominator, or the number of ways the committee can be appointed. And in the numerator, we want the number of ways that we can choose the 3 youngest qualified candidates. This is actually not too bad at all. If we had the birth dates of everyone, all 16 of those qualified candidates, and we arranged them in order, if we even knew their time of day, just in case somebody had the same birthday, if we knew that the minute that they were born and everybody was born during a different minute, then we could definitely arrange the candidates in order from youngest to oldest or oldest to youngest. Either one would be fine. So in that way, there would only be one way that you could choose the 3 youngest. There are only 3 in that list of 16 qualified candidates that would be the youngest, and we want them in the correct order. Oh, wait. Actually, no, that's right. There's only one way to do that, and there are 560 ways that committee can be appointed. So I'll go back to sharing my screen. See, 1 out of 560. And my lab statistics likes it. Now, before we go on, I want to go back to my piece of paper and talk about formulas. I used an intuitive approach for all of these, all the different parts of this problem. You can use the intuitive approach as well. but you may prefer to use formulas. Some students do like the certainty that's provided by that formula. So let's go back and look at how we would find exactly this, or answer the exact same questions, but using the formulas. Okay, so we've got this information here. And it says, how many different ways can the officers be appointed? Now, when you're talking about the ways that the officers can be appointed, the order matters, because you're going to appoint one of these guys, and then you're going to appoint one of these guys, and then another one, and then another one. Which person is serving in which role is significant. Since order matters, that means we're dealing with a permutation. And the formula that we have for the permutation of, if we've got n people to choose from, and we're choosing r of those, the permutation comes from taking n and finding its factorial and dividing by r factorial. In this case, we have 16 people to choose from, and then we're choosing 4 of those, so we divide by that. Oops, I'm sorry, that's not right. It should be n minus r. That should be 12 factorial. There we go. So you've got n, which is 16 factorial, divided by 12 factorial. And that's the same as 16 times 15 times 14 times 13. And then you've got a 12 factorial over here, and you're dividing by a 12 factorial. And so the 12 factorials cancel, and you just are left with the 16 times 15 times 14 times 13, which is exactly what we got when we used that intuitive approach. We said, if I'm choosing a president, I've got 16 options. If the president can't serve as CEO, COO, or CFO, I've got 15 options for the next one, and then 14 options for the next one, and 13 options for the next one. So I just multiplied those together, and I said I only had 4 officers, so I stopped, and that gave me this. Now, if you don't want to do that, you can always use this formula. It's going to be on this sheet, and you'll be able to use the sheet of tables and formulas during your test. And it says that if you're dealing with a permutation, remember, permutations are arrangements where order matters. You take the number of items that you have, or in this case, number of people that you have, and you divide by the number of people minus the number that you're selecting. I'm sorry, I really messed that up when I wrote that r factorial there. It should have been an n minus r factorial, and it's really messy now. But hopefully you get the idea, because we're choosing r of those. So you've got n, or n factorial, that's at 16 factorial here. And you just multiply those guys together, and you divide by the 16 minus 4, because we're choosing 4 out of 16. That's 12 factorial. And 16 factorial is 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But that last part, starting with 12, and multiplying all the way down, that's the same as 12 factorial. So the 12 factorial up here and the 12 factorial down there cancel, and we're left with exactly what we get using that intuitive approach. Now over here, I used an intuitive approach as well. Now this might be less intuitive for most people, and most people might prefer the formula in this case. We're dealing with selecting a committee. So when we're talking about a committee, the order does not matter. That means we're dealing with a combination. And the formula for combinations is this. You take n factorial, and you divide by r factorial and n minus r factorial. And if you're wondering where those come from, basically what you're doing is this n factorial over n minus r factorial. That's that 16 factorial in this case, because we had 16 people to choose from. For the committee, r is equal to 3. So I've got 16 factorial here over 16 minus 3 factorial. Let me write this down. If I do this example using the formula, I've got n equals 16, r equals 3, because the committee has 3 members. Then the formula says, got 16 and we're choosing 3. You take 16 factorial and you divide by 3 factorial times 16 minus 3 factorial. Now, I actually don't have this memorized. I have the intuitive approach memorized, and I use the intuitive approach to write down the formula. I would love it if every student in this class used the intuitive approach and understood how it worked, because the intuitive approach gives you exactly the same answer that you get from this formula. This formula is just a formalization of that intuitive approach that we're using. So let's talk about how this is equivalent to that. That's 16 factorial over the 16 minus 3 factorial. 16 minus 3 is 13. This is what we've got here. I'm just rearranging this. I'm just calling that a 1 over 3 factorial. I'm putting that off to the side for right now. And then this 16 factorial over 13 factorial is 16 times 14, or excuse me, times 15 times 14 times 13 factorial, 13 times 12 times 11, and so on. All divided by 13 factorial, and those cancel. And so what I end up with in the numerator is 16 times 15 times 14, which is exactly what I got in this numerator here using the intuitive approach. I said, I've got 16 people to choose from for that first member of my committee. I've got 15 for the second member of my committee and 14 for the third member of my committee. So if the order mattered, if which seat those people were sitting in mattered, the answer would be 16 times 15 times 14. That would be a permutation and we're done. So this is the permutation of choosing three people when you've got 16 options. This is assuming that order matters. But then we're saying to ourselves, order doesn't actually matter though. If these are my 3 people on the committee, it doesn't matter if I chose Sally, then Jade, then Joe, or if I chose Sally, then Joe, then Jade. That is considered exactly the same committee as this, and that's considered the same committee as this, and so on. All 6 of these are the same committee. So when we did this, when we took order into account when we didn't want to, we accidentally counted that committee of Sally, Jade, and Joe. We counted that committee 6 times when we only wanted to count it once. So instead of counting it 6 times, we divide by that 3 factorial, and that 3 factorial is the r factorial in the formula for combinations. So we've got 16 times 15 times 14 over 3 times 2 times 1, and that simplified to 560. Now, I am still much more a fan of this intuitive approach as opposed to this formula, but some students really like this. They like to know if order doesn't matter, it's a combination, therefore I just take the number of people I have to choose from or the number of items I have to choose from, and I divide by the number that I'm choosing times the number I have to choose from minus the number that I'm choosing, and that's all of those are factorials. So that's a formula, you can use it, and you can use this procedure to get the same answer, but I would rather that you understand intuitively what's going on. I've got 16 options for the first seat in the committee, 15 for the second, 14 for the third, and order doesn't matter, so I'm accidentally counting them all 6 times when they're at the same committee by doing this multiplication. So to account for the fact that I accidentally counted them 6 times by doing this multiplication, I'm dividing by 6. I'm dividing by the number of ways we can arrange those 3 people in order, which is, well, I've got 3 options for the first position. And then after you choose the first position, you've got 2 options for the second, and then you've got 1 option for the last. So there are 6 different ways, as we see here on the list to the right. And then this last one is just using these counts that we found, or this count that we found in Part B. I hope that helps you. If the intuitive approach doesn't help, you can always just use this formula or this formula, but I highly recommend that you use the intuitive approach. That way you know that you know why these formulas work.